Assalamualaikum. Today I am going to explain on the control of single acting and double acting hydraulic circuits. What is single acting hydraulic circuit? It is a circuit that uses single acting cylinder as its main component in the hydraulic system. What is single acting hydraulic cylinder? Single acting hydraulic cylinder is the simplest type of hydraulic in the hydraulic system that only exert force in either extend or retract. As you can see in the video, single acting hydraulic cylinder only extend or retract one in a time. Next, we are going to see the example of single acting hydraulic circuit and identify the components in the circuit. The first one is a single acting hydraulic cylinder with a spring retard, which is its main component in the single acting hydraulic circuit. The next one is a 3-2 directional control valve or DCV, a lever, a pressure relief valve, a general return line, a hydraulic pump, a filter, and inlet pipe. Next, we are going to move on to the control of double acting hydraulic circuit. What is double acting hydraulic circuit? It is a circuit that contains double acting hydraulic cylinder that generates force both during extension and retraction in this hydraulic system. As you can see in the video, unlike the single acting hydraulic cylinder, the retraction and extension happen simultaneously both in the time. Now we are going to see the example of double acting hydraulic circuit and identify the components in the circuit. We have inlet pipe, a filter, a double acting hydraulic cylinder, a lever, a 4-2 DCV or directional control valve, non-return valve, a pressure relief valve, and a hydraulic pump.
A single-acting hydraulic cylinder is simple, so there is less to maintain, with only one line to the action of the cylinder is determined entirely by the pressure on that one line. Based on cylinder action, we can classify the cylinders as single-acting or double-acting. Single-acting cylinders are used where force is required to be exerted only in one direction, such as clamping, feeding, braking, and etc. Figure below shows the schematic diagram of a single-acting cylinder. This is the single-acting hydraulic cylinder circuit. As we can see, there is a pump, filter, reservoir, pressure relief valve, solenoid valve, hydraulic accessories, and also the single-acting cylinders. In the spring offset mode, full pump flow goes to the tank via the pressure relief valve. The spring in the rod end of the cylinder retracts the piston as oil from the black end drains back to the tank. When the valve is manually actuated into its left envelope flow path configuration, pump flow extends the cylinder. So this is the left envelope and this is the right envelope. At full extension, pump flow goes through the relief valve. The activation of the DCV allows the cylinder to retract as the DCV shifts into its spring offset mode. Here are the examples of where the application of air pressure produces a thrust pushing the piston. So this is pushing. And the application of air pressure produces a thrust pulling the piston. Hydraulic cylinders are the moving force behind many commercial and industrial manufacturing concerns. There are three examples of application of single-acting hydraulic cylinder. In civil engineering, it is used in bulldozers and excavators. In mechanical engineering, it is used in plastic forming machine. while in aerospace industry, it is particularly for such devices as landing gears and wing flaps. Now we're moving on to the double acting cylinder. Double acting cylinders have a port at each end and a move to the piston forward and back by alternating the port that receive the high pressure air, necessary when a load must be moved in both directions, such as opening and closing gate. Figure below shows the schematic diagram of double acting cylinder. This is the example of double acting hydraulic cylinder circuit. The components is reservoir, filter, pump, pressure relief valve, solenoid valve, and double acting hydraulic cylinder. The operation: when the four-way valve is in tandem design, the cylinder is hydraulically locked. Also, the pump is unloaded back to the tank at essentially atmospheric pressure. When the four-way valve is actuated into the flow path configuration of the left envelope, the cylinder is extended against its load force. As oil flows from port B through port A, also oil in the root end of the cylinder is free to flow back to the tank via the four-way valve from port B to port T. Note that the cylinder could not extend if this oil were not allowed to leave the root at the end of the cylinder. When the four-way valve is deactivated, the spring-centered envelope prevails and the cylinder once again hydraulically locked. When the four-way valve is actuated into the right envelope configuration, the cylinder retracts as oil flows from port B through port B. Oil in the blank end is returned to the tank via the flow path from port A to port T. At the end of the strokes, there is no system demand for oil. Thus, the pump flow goes through the relief valve at its pressure level setting unless the four-way valve is deactivated. In any event, the system is protected from any cylinder overloads. This is the example of the positive push stroke and the negative pull stroke. As we can see, this is the force where there is pull as happened to the cylinder. And when the force is pushed, this is what happened to the cylinder. You could use two single acting cylinders to separately produce push and pull motions. This could be benefit in a situation where you require positive end of stroke positioning in both directions. Here are few application use of double acting hydraulic cylinder in this industry. First example is elevator. Second one is forklift. The third and last is aerospace industry, which is landing gears.
So, do you know the advantage of this hydraulic circuit in the industries? Do you know, right? Me too! Nah, just kidding. So, now I would like to explain about the advantage of this hydraulic system in the industries. Firstly, it's easy to control and accurate because a system operator can easily start, stop, accelerate and slow down the system using simple levers and push buttons. Secondly, it's simple and easier to maintain because this system use less moving parts. Thirdly, it's easy to spot leaks of a hydraulic system. Fourth, it does not cause sparks, so these systems are safe to use in chemical plants and mines. That's it. Lastly, the amount of the force on the driving system can be adjusted with the force multiplication. So that's all the advantage of this hydraulic system. Good? I'm good too. This word, every advantage have their own disadvantage like pros and cons, right? So now I would like to continue to explain about the advantage of this hydraulic circuit. Firstly, it main requirement of any hydraulic Leakage of this fluid will create environmental problems and safety issues, so it may be dangerous for us if the liquid leaking. Secondly, requires continuous filtration. Contaminants present in the hydraulic fluid will damage the system performance and productivity. Hey, do you know wrong selection of hydraulic fluid for a system will damage the component? Lastly, the proper maintenance is very required. Why? Because we need to prevent from the leaking that will create environmental problems and safety issues. So that's all of the disadvantage of the hydraulic system. Thank you.